Hello and welcome back to another session of Pistonics, a series where we do the catchit game. It's Byron speaking. And in the previous session we've implemented the attractive forces that are created by the blue balls that right now probably don't occur too often here. And what I would like to do now, maybe I should put on some better testing here. So like this, higher chance to get these special balls and special obstacles. And what I wanted to say is that I would love to repel these balls in the moment I hit them, so that you spice it up a little more and it's not like, oh, it goes through you. So why not change their velocity, like for real, not gradually, but for real. So there is this intersect test here, and here we actually just want to set these things to the velocity of our super strong hunter, because we can't really prevent the user from being slower than that or whatever, and we can't kind of slow the user down, not just yet. And there are ways to do that, but I would refrain from doing this. So this is why we just basically have to get some hunter velocity. And the cool thing is that we should be able to just add the field here and then use it, velocity. So I think, and initially we don't even know that stuff. Hunter, force, velocity. Do I set the velocity elsewhere? Yeah, actually no. So that's a vector 2. Let's just set it to 0.0, 0.0 explicitly here. And we are done. Good. So now we have a velocity field. I think every time we set the hunter position, we want to update the velocity. Let's just compute it as hunter velocity shall be vec to sub, and then is the new position minus the last one, right? So like this, and then we can override the position as we like. Cool. And now that we have this, we can go back to our intersection code and just drop it in, right? So in the moment we have intersection, then we just set the velocity of the intersected obstacle to velocity is the hunter velocity. S hunter velocity. That's all copy. So we should be fine like that. So let's see how that works, if it works at all, if it compiles at all. But in theory, kind of. Yeah, it's way too weak. It should bounce away, but it kind of works. Yeah, let's get why is it so weak? I mean, we are really fast here. Boom. And it doesn't seem to care, huh? We might even change the position to be elsewhere, but yeah, that's weird. But this should also be, I mean, it goes into the right direction, so I assume. And it's also weird that you don't always hit them for some reason. Same with the blue ball. Yeah, frame rate, I think I reduced it to 24, which might not be enough. It looks a bit, I mean, yeah, should be 60 FPS. Maybe this would also change it to the better. Yeah, but I kind of like this, even though I think it should be scaled. Maybe I just scale it by 2. Vec to scale, hunter velocity, by 2, and that should now be stronger. I'll just make sure that even in these runs it kind of gives you the strong feeling of action. Ow, that totally hit me. Here we go. Boom. And I set the velocity, right? So yeah, that was more like it. But if I am that fast, the velocity seems to be just not strong enough. If I'm moving that fast, why doesn't it seem that fast when it bounces off? And maybe I want to set the vector to something that actually bounces off. So yeah, let's do that. So let's compute the position differences between him and me, between vec2 sub, and then I think it's between him and me, huh? The obstacle object position minus hunter object position. So it goes into a different direction, and that one we scale by the length of the hunter velocity. Back to lengths. There we go. For now unscale. So let's see. Back to sub. This one. And then scale against the length of the hunter velocity. That could look nicer, because it should push it kind of into the direction where you are like a pool game, right? Kind of. Maybe I have to invert something there, but generally it should be that. Did you mean either? No, I meant s.hunter, s.hunter. That's what I meant. Good. Let's try that again. Oh. Huh. Kind of goes, I mean, this worked. This worked. It kind of works, but probably your own velocity should factor in there, huh? Not only the position. So maybe that's how you do it. You just take the average of these two, huh? I think that's what you want. Yeah. So let's add them then. So your velocity plus my velocity and then you scale it by 2, by half, by 0.5, like this. Yeah, so that should probably be more like it. Velocities are at the origin, so you can just do this, get a new velocity, and let's see. Oh, maybe we want to invert this as well. So wait, yes, let's just say you invert the velocity and then you add them. Yeah, I think then you get the desired effect. Then it goes off with high speed into the other direction. I think that's how it goes. So you take my velocity, take the inverse of yours, and that is it. So invert yours, minus 1. Jesus Christ. Not enough space for anything. So like this, then you add mine, hard to read, and then you scale it by 0.5 to get the average. And that is that. So there is a comma missing, at least, even more. Didn't I just add the comma there? So, curiosity. Boom. Okay, now it's... Yeah, for some reason it doesn't collide all the time. Oh, here's one. Excuse me. This worked not at all. Way too weak. Probably you don't want to scale it down or something is going wrong there. So what if I just add this stuff without bringing it down like that? So I invert the obstacle velocity and add my own, and that's a new one. So that should go off with high speed and look like a real collision, huh? Yes! So my velocity is nothing, and they just bounce off with maximum speed. Yeah. Even though that looks very odd. Yeah, because this thing is just inverted, huh? So yeah, maybe you actually want the new direction. Yeah. So let's compute a new direction. That is the kind of angle, so the position matters here. So instead of this, we get the new direction. Like to sub between the positions of the obstacle, object position, and me as hunter object position. And this one we unify and then scale by the velocity of the... Yeah, let's do that. Let's get a unit vector out of that. Unit, is there something like it? Or normalize? Normal. So where's my math library? Come on. MacMath. So unit or normal. Normalized. Normalized difference between two vectors. Yeah. So back to normalized. Yeah, so that should be cool. Yeah, let's have a let new velocity be this one. Then we just add new velocity and my hunter velocity. So basically that's kind of in the opposite direction, but based on our collision. So that is that. Then we normalize it back to normalized. Voila. And then we multiply it by the length of the